去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘都遗忘，遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
Oops. Hello. Welcome to the Shashank Show. And today we'll be solving another some DSA very easy question. And the reason behind picking only easy questions is to focus more on consistency rather than the quality and the quantity of questions. We know that solving these types of questions won't help very much, but what I'm after is actually the consistency that we'll earn solving problems. So the main idea is to solve problems soon after I get up, and henceforth this stream. And let's see what question are we going to do today, and I'll quickly check that if I'm audible. Yes, I am very much audible. Okay. Now, I hope you are liking the background music.
遗忘遗忘都遗忘，去年的烦恼和姑娘。
Okay, I guess my screen is visible now. Yep. Let's see. Find the count of magical numbers from 1 to n. A magical number, if convert to binary, replace 0 with 1s and 1s with 2s in binary string. Calculate sum of all dates in the binary string and resultant must be an odd number. Welcome to my stream. Oh my god, So many viewers. I'm glad you came today. Today is going to be a very fun session, as you can already uh, uh, look. What do you mean product focus? I'm super focused. Okay, for the because of viewers special demand, I'll make them hear one thing. Tell me how's it?
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔幻，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
Hello. Check. Viewer, did you like it? Thank you. Iwan, Dong Iwan. First we convert the number to binary, and then we replace all the zeros with 1 and all the ones with 2 in the binary string, and calculate the sum of all the digits in the binary string, and resultant must be an odd number. Okay, and after checking all these conditions, we'll find out how many magical numbers do we have from 1 to n. Perfect. It's a good question. It's a fun to write question. It's nothing crazy, but it's fun to write question. I don't think there is any super complex details hiding or super complex or any hidden cases that we won't be able to solve, but let's find out. Iwan, Tong Iwan, Jinjit Wanda Tong Iwan. So I'll tell very quickly what the question is trying to tell us, what the question needs out from us. So let's assume if first of all the input, I'll tell you about the input. Input is 1 and input is n, and n can be let's say n can be 100. Okay, so for every number between 1 to 100 we'll check the following set of conditions. What, let's say if the number is 100 and we'll check for the particular number 100. Okay, so we'll first convert this number, this is in decimal, and we'll convert it into binary. Now what is the binary of 100? That is something that I need to see if we really want to do it. Why not, let's take a smaller number for the first example 5. Okay, the number is 5. Okay, of which we have to do all these things. So 5 is in decimal, then we do take out the binary, then it is 4 and 1, correct? Yes, so this is the binary of 5. Now for every number that is 1, we'll write it as 2, and for every one we'll write 0, we'll write 1, and for every one we'll write 2 again, and then we have to calculate the sum of all the digits. The sum of all the digits is sum of digits is 5 over here. There must be an odd number, and the resultant must be an odd number, and the sum of all digits is 5. Wow. The resultant must be an odd number or the same number. This, somehow it is same. Let's see for 6. 6 it will be this, and it will be 2 2 1, and it will be 5. Yes. The resultant must be 5. So the number, if this result, so that's not the case. It somehow happened that this number became 5 only after all the conversion that were given, and the resultant must be odd. Okay, so div by the mod 2 must give 1. Okay, and hence if this is the case, then we have our number. So we have to write, we have to count. Okay, so we have to count all such numbers. You have to count all such numbers. Okay, let's do it with a timer. Iwang iwang tong iwang. Num num num. Yes, 10 minutes timer would be fine. Okay, we'll check quickly over here if you're missing something. Perfect. Is one number is higher than one? What? You're thinking correctly. I think I can directly write the code for it. Program. Yes. Let's see how much can we write in the 10 minutes that we have set for ourselves. 8 minutes 15 seconds is what we have in hand right now. So two must be the answer. And what we are doing, we are taking the number and we'll check. Okay, so we'll simply run a for loop. I have messed up earlier in questions as simple as these. So Okay, so and we'll start from 1. I must be more mindful and thoughtful while I write. For every number that we have, we'll simply check. So we'll write check magical, and we put the number I. And we return the count. This is a simple code. Okay, but now we have to write the condition for the magical function. Okay, and what we can do is as we are making two functions, it's not good, but yeah. Static boolean, sorry. Sorry for the background noise, and for a little while I'll just mute my mic.
遗忘遗忘都遗忘，去年的烦恼和姑娘。
莫慌莫慌都莫慌，今年的姑娘更漂亮。
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 遗忘遗忘都遗忘，去年的烦恼和姑娘。
莫慌莫 魔幻都魔化，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
魔幻魔幻都魔化，今年的姑娘更漂亮。
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 遗忘遗忘都遗忘，去年的烦恼。
How do we do it normally? Okay, understood. I have understood. So sometimes you forget the easiest of easiest things. 0 and we are left with 1 here and we are left with 0 here. So the conversion of 10 oops. So the conversion of 10 will be 1 0 1 0. Okay, now we'll check it. This is 1 and this is 2, this is 4 and this is 8. Correct? 8 and 2 makes up 10. That's correct. Okay, so we have to do this. Or if see, I know that there is a method with some bit to convert the number into binary, but for we don't remember that, we'll still stick with the cliched method, or can we even do that? Yes, why you get stuck in a logic where we really don't want anything out of it. Mm, okay, so there is this built-in function also that if we would have known, we would have utilized. But let's understand the logic. Integer are two binary string. So for so for mm, every number, what we are doing is we are first of all dividing it by, let's assume that we have the number is 5, and the number is 5, so and divided by 2, and modulo 2 will give us 1, and so okay, so this will give us okay. Okay, so number that we'll have is 1. Okay, the remainder n will be 2, so this will be 5 divided by 2, and n will be 5 divided by 2 will be the is the quotient. So quotient, right? We have 2 here. The 2 more 2 is 0, correct? And 2 divided by 2 equals to 1. And 1 more 2 is 1. Sorry, 0 and 1. Correct. And that is 1 divided by 2 is this is less than 1, so it is 0. Yes, so we have 101, that is correct. So for checking the binary, we simply write this. Then we have so 2 becomes 1 and 1 becomes so 0 becomes 1 and 1 becomes 2. So ultimately we want plus 1. Then we just add the current digit, correct? Now it will give us error that that we haven't returned anything, because if the else if doesn't work, we don't know. Perfect. We have written the code. And actually, he doesn't know that what conditions we have, but I think I know that this is correct. And only if we had uh, uh, only if we had uh, some good test cases, then only we'd be able to actually check in depth. But I think that this is it. This is it for the day, and I think that uh, I'll be putting my hands into some more lead code questions today itself. So let's Let's see. Okay, thank you for joining. Tata.
遗忘遗忘都遗忘，去年的烦恼和姑娘。
莫慌莫慌都莫慌，今年的姑娘更漂亮。
遗忘遗忘都遗忘，去年的烦恼和姑娘。
莫慌莫慌都莫慌，今年的姑娘更漂亮。